So next we'll look into transformations. And for this it's useful to have the toolbox, which is this part on the left here visible, and the numeric panel here on the right. So if you don't see the toolbox, press T to toggle it. And if you don't have the numeric panel, press N to toggle it. So and if you have both of them visible, that will help during working with transformations. So one of the most basic operations on objects within a 3D scene is to change their transformation. So to change their position, to rotate them, or to scale them, for example. So I've got a simple scene here. Two objects that have geometry, so the torus and the blender head called Suzanne within the Blender world. And we got this axis object over here, which does not have geometry, but it shows its orientation using this axis. So there's several methods to change the transformation. The first one is using the gizmos, and these are these colored helper items that are visible right now. So I've got the Suzanne object selected. I can pick, for example, the arrow pointing up, and if I click that and move it, then you see that the object transforms in the Z direction, the Z axis that is up. Or if I press the X direction, the red arrow transforms in that direction. The several gizmos. I've got now the move gizmo selected. I can change that, for example, to rotate. And now I can rotate the object around one of the axes, X, Y, Z. Or another one with the white circle over here is to rotate it along the view axis. So whatever you have as a view direction, the white circle will rotate around it. And then finally, there's the scale gizmo that allows you to scale an object. And that can have a different scale in X, Y, and Z. For example, scaling only in X, or if you use one of the squares on the gizmo in two of the directions, so this one is in Y and in Z, without scaling in X. There's also a transform gizmo, which combines all these different modes into one. So using the gizmos is one way to transform objects. Another method is to use shortcut keys. For example, if I select the torus and press the G key, G for grab, and then move the mouse, you can see that I can change its translation. I can move it around. I can then click with the mouse button and it stays in the position that I leave it. I can press G again, and for example, if I want to cancel this operation, I can press escape and it goes back to the position that I started the translation from. So G is for grabbing, S is for scaling, and R is for rotation. And rotation by default is again around the view axis. Now sometimes you want to limit, even with the shortcut keys, the rotation or translation or scaling around a certain axis. And you can, for example, if I press the G again and then press X, it will limit the movement around the x-axis. Or if I press Y, it will switch to a limit to y-axis. You might even want to limit a certain movement in, say, a plane. For example, the XY plane. Then I would press the G to start translation and then Shift Z to get the XY plane as limitation. So when using the shortcut keys to do transformations, there's a very nice feature to do very precise values of transformation. For example, if I wanted to move the monkey head up by 5 units along the Z, we can press the G to start moving, then press Z to limit to the Z axis and press 5 for 5 units up. And we can even still edit this value. So in the upper left, you can see it says 5 along global Z. I can use backspace to delete the 5 and enter 3, or maybe 2.5 or 3.5. And in this way you can do very precise transformations based on numbers that you enter. And this even works for multiple objects, so we can select multiple objects do the same, grab Z, 5, and it will move all of them up. So we've now shown two ways to transform objects. One is through the gizmos, the other is through the shortcut keys. And there's yet a third method, which is using the numeric panel up here to the right. You might have seen the values over there change as we changed the transformation of these objects. And we can enter values here. So for example, if I press the C value and enter 5 in this case, you can see that the active object, in this case the empty, which is the axis, moves up by 5. Or if I enter 3, it will translate to Z is 3. So this is the global transformation. It does not add the transformation to what it was. It just sets the transformation, and it only influences the active object, even though we have selected multiple objects in this case. So it is good to keep in mind that when you're working with these different types of doing transformations, that this way of altering the transformation does only affects the active object. So using this numeric panel up here allows very fine-grained control over an object's transform. But even when you use the shortcut keys, you sometimes want to have more control over the movement. For example, if I grab the monkey head and limit the transformation to the z-axis, normally when I move the mouse, it kind of follows the mouse, which might be too much movement for you, for what you want. But if I hold the shift key while moving the mouse, you can see that the mouse movement is translated into a smaller movement of the object itself. So in this case, you can still have more and finer control over an object's movement. And if you release the shift key, then again you get the coarse-grained movement. So the transformations that we looked into so far were relative to the global scene axis, which is the axis system you see up here or within the scene using the colored grid lines. But sometimes it's useful to have a transformation based on a local axis. For example, if we look at the axis object over here and we rotate a little bit around x, which is the global x-axis, it ends up like this. But now if we want to rotate it around its local z-axis, what do? Well, we can do that with the shortcut keys, for example. If you press the R to enter rotation mode, press the Z key and then again the Z key, we will get the local z-axis of the object and rotate it like that. Same thing if we want to rotate it around the x-axis locally, press R, X, X, and you get the local x-axis. There's two other ways in order to set these axes. Up here, there's a transformation orientations menu. We can switch that to local. And now if we enable the gizmo, you can see that this is aligned with the local axis. And we can compare it by switching it back to the global. And you see that this is the rotation gizmo around the global axis. And another way to access these modes is using the comma pi menu. So press the comma key, will bring up the orientation menu where you have the same global and local options. So we saw earlier that you can enter numeric values to do very precise transformations. That also works for these local orientations. For example, I can switch it back to local and then do a grab x-axis, and you can see that's already aligned with the local axis. And if I now enter a value like 4, it will move along the local x-axis in 4 units. So one tricky thing here is that the values shown in the numeric panel over here are global values. So even though this is a local transformation mode, if I change these values, you can see that it moves along the global x-axis and not the local x-axis. So one thing that we used implicitly so far is that whenever you're doing a scale or a rotation transformation, you're transforming around a certain point in space, so-called pivot point. For example, if I select these 3 objects and rotate around C, you can see that the pivot point is roughly the center of the monkey head. But if I select only 2 objects and do the same thing, then the pivot point is roughly between the 2 objects. Well, the reason for this is that the default pivot point is set to the median point of all selected objects. And you can change the pivot point mode by using the menu up here. So the default is median point. Or you can use the period key to bring up the pi menu for the pivot point, which shows the same options. So another option that could be useful is, for example, to use the active element option. This now means that the active object defines the pivot point. So with these 3 objects still selected, rotate around C, you can see that it rotates around the center of the active object. And by changing the active object using the normal selection, we can change how the objects are transformed. So another interesting option when it comes to the pivot point is to use the only locations option. When we enable that and rotate these objects, you can see that only their location is changed, but not their orientation in space. And yet another option is to disabled his only location and used the individual origin option. And now if we rotate, they all rotate around their own position. And within the exercises, there's one to test all of these different modes and see what they do in detail.